About 50 years ago, an astronaut returning from the moon experienced things that he couldn't find a scientific explanation for. So, with some colleagues, he launched a new science focused on the mind and how it works in the body and across space and time. It's the field of Noetics, where the tools of modern science are used to help us understand how what we think and feel affects us and the world around us. Now, this is Dr. Ruth Miller's Noetic Moments from the studios of KXCR Community Radio in Florence, Oregon.
And this is Noetic Moments, where we explore the field of research that discovers what consciousness is, what it does, how it works, and how our lives could be very different if we understood it better. I'm Ruth Miller, a longtime student of consciousness studies, cybernetics, and anthropology, and through this series of programs, I'm introducing some of the people whose work has defined this field of research and explaining some of their ideas and experiments. I'll also explore relevant news items and answer questions that you send to my email address, ruth@noeticmoments.org. Now, most of you know that in the world of medicine and psychology, consciousness is defined as being awake and aware, knowing what's going on around us. We see it on TV all the time, and maybe have had an EMT or a doctor ask us a few questions to see if we are really conscious. In the field of noetics, though, consciousness is so much more. It's not only the processes and products of mind, it's those that are in our awareness and outside of it, and it's those profound human experiences that shape our lives. And as we do more and more research, we realize that consciousness is not limited to individual minds and is perhaps what connects us all. So far in this series, we've looked at a number of models of what consciousness is. From the beginning, we started with Sigmund Freud and Carl Jung's ideas from the early 20th century that explained how much of what goes on in the mind is not in our normal awareness at all. It is, in fact, unconscious. They defined various forms of superconscious and subconscious, and we looked at some of those structures. Then we looked at the idea of states of consciousness, that we might be more or less aware of different aspects of our being, as presented by Charles Tart in the 1960s. We talked about Julian Jaynes, who said that the right brain and the left brain are separated, and that affects our state and awareness. Then we looked at some of the field models of mind that have been developed by Rupert Sheldrake, Kurt Levine, and others, trying to explain how it is that mind affects and is affected by the body and other things faster than nerve signals can travel. Which brought up, of course, how quantum mechanics relates to consciousness, as described in the work of David Bohm, Dana Zohar, Amit Goswami, and many others. And as soon as we get into quantum mechanics, we have to look at the larger notion of a field of consciousness, which was called a noosphere by Pierre Teilhard de Chardin, the global brain by Peter Russell, and the global mind by Ervin Laszlo. Alongside all of these developments emerged the field of transpersonal psychology, applying some of these understandings in therapy and research as we explored the founding and the methods used there. We then looked at the biology of consciousness, particularly the work of Bruce Lipton, whose understanding of how chemicals and cell walls interact led him to believe in a biology of belief. And Candace Pert, who explained how that worked in her idea of molecules of emotion, looking at how hormones and cells interact. Both of those were beautifully described, if you haven't seen it yet, in the movie What the Bleep Do We Know? As we went forward in time, we began to see that there's an increasing interest in something called coherence. This is a state of consciousness in which the mind, the emotions, and the body, particularly the heart, are all in alignment. None of the vibration patterns are discordant with the others. As we looked at experimental As we looked at experimental results supporting these ideas about consciousness, we saw that telepathic communication appears to happen between two people, and that the mind does appear to affect matter, and that some people are able to see beyond, with their inner vision, what their eyes can see. And we looked at the different states of consciousness that we operate in every day and how those can shift and change our ability to do some of those things that the experiments showed us. Which brought us into the idea of frequencies and how we can choose to operate in higher and lower frequencies of vibration patterns in the brain and heart. And we used the work of Penny Pierce, the study of cymatics, and the water crystal experiments of Masaru Emoto to help us understand that. For several episodes following that, we began to understand the healing process in the body and the role that consciousness and those vibratory patterns play in the body's response to threats and distress. Then, in the last few weeks, we began looking at the brain, which is the bridge between mind and body, and most scientists think is the origin of our consciousness, but our studies are showing us otherwise. So you can catch up on those past shows on the KXCR.net archives. Click on that little cloud up on the banner at the top of the screen on KXCR.net, and on our website as well, www.noeticmoments.org, where you'll also find links to the clips, the books, and the authors that I mentioned during the show. Today, as we continue our exploration of the brain, I want to backtrack just a little bit and remind us that the brain contains billions of neurons, some say 100 billion, making roughly 500 trillion connections. Now, a neuron is a cell that looks a lot like a tree root with little root hairs or dendrites extending out. So each neuron, 100 billion of them, has roughly 5 connections, so that's 500 trillion synaptic connections. And those fire 5 to 50 times every second. So we're looking every minute at quadrillion or so, a minor number, of synaptic activations occurring in our heads. You can imagine what that background noise is like as those little chemical signals are going off. And what we're talking about is an electromagnetic, quote, spark whenever an electrochemical shift happens. So the end of one dendrite encounters the end of another dendrite and jumps over a part of a chemical, a part of a molecule. And that is experienced in the world around us as electromagnetic sparks. Now, we can see that there are many, many, many possible states with all those dendrites firing and all those neuron connections happening. And all those chemical shifts, all those electrochemical signals are picked up by certain kinds of sensitive instruments like the EEG, which we'll talk about today and which I'll let this YouTube video introduce.
So the question is, how are we going to look at that activity? One method that we can use is called electroencephalography, or EEG. For this, we place a number of sensors on the head. The number of sensors can range anywhere between 16 and 128. And when you connect the machine to a computer, you will see a variety of squiggly lines on your screen. But what exactly are those squiggly lines? Well, for this you need to know that when a brain cell, or a neuron, communicates with another neuron, it sends a signal that is generated by the influx and outflux of charged particles. This means that there are areas around the neuron that are positively charged and negatively charged. The charge of a single neuron we cannot measure from outside of the head. The signal is just too small, and it cannot travel through the skull. However, if there is a difference in charge of multiple neurons, let's say 100,000 or so, then we can pick up a signal from outside of the head. However, keep in mind that the signal is still very, very small and the signal is first amplified before we can actually read it. Depending on the directionality of the charge, the signal that we measure either goes up or down. Now you may think those signals are looking really nice, but what do they actually tell us? What does it say about brain activity and how does that relate to anything in our behavior? Well, if you look at the signal, you will see that there is this pattern or rhythm in there. That's why we call them brain waves. And how fast these waves go up and down and where we can find them in the brain does tell us a little bit about the function of that brain area. For example, if you are asleep, you will see very slow waves called delta waves over the entire brain. However, when you are awake and you're in some kind of relaxed state, you will see faster waves such as alpha waves or at the back of the head where the visual cortex is. And when you're doing something where you need a lot of attention, then you will see faster waves such as beta waves in the frontal part of the brain.
So we have a very useful tool here for seeing what's going on in terms of activity in the brain, but we don't really understand much about it till we interpret all those squiggly lines. And that's what the next video will help us understand, the next YouTube audio that I will be linking to on the show. So here we go.
We can measure brain waves using a technique called electroencephalography, in which small detectors called electrodes are placed on a person's head. We can have a visual printout of what the brain is doing. In beta, ordinary, everyday waking consciousness, your mind is focused, it makes connections quickly, easily, and you're primed to do work that requires your full attention. In the beta state, neurons fire abundantly. Beta waves range between 13 and 40 cycles per second. The beta state is associated with concentration, alertness, hand-eye coordination, and visual. We know that mind is more than just brain, but our brain emits electric signals. And we can measure these and see what the brain is doing. We can measure brain waves using a technique called electroencephalography, in which small detectors called electrodes are placed on a person's head. We can have a visual printout of what the brain is doing. In beta, ordinary, everyday waking consciousness, your mind is focused, it makes connections quickly, easily, and you're primed to do work that requires your full attention. In the beta state, neurons fire abundantly. Beta waves range between 13 and 40 cycles per second. The beta state is associated with concentration, alertness, hand-eye coordination, and visual acuity. When we slow the brain down a little bit, we move into alpha, more relaxed. When you're truly relaxed, brain activity slows from the rapid patterns of beta into the gentler waves of alpha. Awareness expands. You experience a liberating sense of peace and well-being. Alpha waves range between 7 and 12 cycles per second. Alpha is also the home of the frequency known as the Schumann resonance, the resonant frequency of the Earth's electromagnetic field. Slower still, theta. Going deeper into relaxation, you enter the elusive and mysterious theta state, the brain state where magic happens, and the crucible of your own neurological activity. Theta can bring you deep states of meditation. Theta waves range between 4 and 7 cycles per second. Slower still, delta, aka sleep. Long, slow, and undulating. Delta is the slowest of the 4 primary measurable brainwave frequencies, most associated with deep sleep. In the delta state, we can release human growth hormones, beneficial for healing and regeneration. Delta frequencies are essential to the healing process. Delta waves range between 0 and 4 cycles per second. And then there's gamma. Above high beta, exceedingly rapid waves in an EEG, characterized by a softening of focus and expanded spatial awareness. A gamma wave or gamma rhythm is a pattern of neural oscillation in humans with a frequency between 25 and 140 hertz. This frequency is accessed during intensely surrendered states of meditation or during a conscious quantum entanglement. Moving into gamma enables access to the undifferentiated quantum field where literally anything is possible. Acuity. When we slow the brain down a little bit, we move into alpha, more relaxed. When you're truly relaxed, brain activity slows from the rapid patterns of beta into the gentler waves of alpha. Awareness expands. You experience a liberating sense of peace and well-being. Alpha waves range between 7 and 12 cycles per second. Alpha is also the home of the frequency known as the Schumann resonance, the resonant frequency of the Earth's electromagnetic field. Slower still, theta. Going deeper into relaxation, you enter the elusive and mysterious theta state, the brain state where magic happens, and the crucible of your own neurological activity. Theta can bring you deep states of meditation. Theta waves range between 4 and 7 cycles per second. Slower still, delta, aka sleep. Long, slow, and undulating. Delta is the slowest of the 4 primary measurable brainwave frequencies, most associated with deep sleep. In the delta state, we can release human growth hormones, beneficial for healing and regeneration. Delta frequencies are essential to the healing process. Delta waves range between 0 and 4 cycles per second. And then there's gamma. Above high beta, exceedingly rapid waves in an EEG, characterized by a softening of focus and expanded spatial awareness. A gamma wave or gamma rhythm is a pattern of neural oscillation in humans with a frequency between 25 and 140 hertz. This frequency is accessed during intensely surrendered states of meditation or during a conscious quantum entanglement. Moving into gamma enables access to the undifferentiated quantum field where literally anything is possible.
When we look at this marvelous squiggly set of squiggly lines, what we're looking for is disharmonies, we're looking for length of line, we're looking for events that are suddenly very up and down, very extreme. That would be a seizure, for example. But remember what we've talked about in the past. Even though different parts of the brain are associated with different activities, for example, the temporal lobes tend to be associated with hearing, and the back lobe, the occipital lobe, tends to be associated with visual. Nonetheless, if I imagine a sound or if I imagine an image, those parts of the brain will be activated along with several other parts of the brain. So they may have more activity in those areas, but they are not isolated. And this is the main difference between modern understandings of brain function and the kinds of understandings that most of us were taught in school. So, why am I looking at the brain so much when what we're talking about is consciousness? More and more research is suggesting, and we'll talk about some of that research as we go forward, it looks as if the brain is not the source of most of that activity, but is functioning as a receiver-transmitter, so that if I am in a state of consciousness that is receptive to images or sounds from the consciousness around me, the field of consciousness that I am, so if I'm in an alpha state or a theta or a delta state, I'm more likely to be receptive to what's going on in the field of consciousness. If I'm in a beta or gamma state, I'm probably filling the brain activity with so much static that it's not possible to receive. We've discovered in those studies on coherence, remember when we talked about coherence, that when the heart and the mind and the emotions and the brain are all working together, we tend to be in alpha level or theta level. There is more slow-paced, relaxed kind of activity in the brain, and there isn't all this chatter trying to keep us occupied, trying to keep us from knowing what is going on, and background noise. So I hope that's been helpful. And we will talk more about the brain and the mind as we go forward in this program and the relationship between them. All right, so that brings up more about books. I had the delightful experience of wandering around Powell's bookstore with a very good friend who I understand listens to this show. Thank you very much, my dear. And we found a marvelous book called Your Brain Explained. Oh, and for those of you who don't know, Powell's is also called the City of Books. It's in Portland, downtown at 10th and Burnside, and it's like a city block that's 3 stories high with books everywhere, many of which are used, thank heavens. And so it's a marvelous place to spend a few hours or a day or a rainy evening, which is what I did when I lived there. Okay, Your Brain Explained is by Mark Dingman, Dingman, PhD, and he has a YouTube series called 2-Minute Neuroscience, which is not where I got that particular YouTube, but his version on EEGs is quite good. And he talks about the various experiences we have and then how the brain is related to them in this book. The way he's organized the chapters is... his sections are fear, memory, sleep, language, sadness, movement, vision, pleasure, pain, and attention. It's really, really well done. It's very easy to read. There's a good index in the back. The author received his PhD in neuroscience in 2013, from the Pennsylvania State University, and since then he's been a faculty of the Behavioral Health Department at Penn State. He's got all kinds of really good references and notes. They're not footnotes if you don't like those. And in his afterword, he says, our understanding of the brain is always evolving. And like other scientific disciplines, neuroscience is constantly correcting itself. I love hearing a scientist say that. We often spend decades relying on one paradigm of how the brain works, only to find that paradigm needs to be modified drastically when new evidence comes to light. Far from being a shortcoming, however, this self-correcting process is one of the greatest strengths of the scientific method. Hooray, Mark! So, he says, although we can't ever be certain the conclusions we make about the brain are representative of reality, we can be confident any mistakes we have made will eventually be rectified by later scientific investigations. So, what he's created here is a quite up-to-date understanding of how the cells and various portions of the brain work and how those molecules of emotion affect the brain and other parts of the body to some extent. He talks about that. And he gives you both case studies and experiments. All right. Well, that sound tells us that it's time to look at the news. And oh my goodness, there's all kinds of wonderful things happening in the area of mind-body research in the news today. And the article I want to talk about just came out July 26. The summary: the subthalamic nucleus in the brain communicates with the motor system to help the body stop an action, researchers confirm. Yeah, well, we kind of knew that, but at the University of Iowa, they've confirmed that the area below the thalamus of the brain is critical to governing how the mind communicates with the motor system in the body. The motor control system is usually thought of as the brain stem down through the spinal cord. And they're very excited about this because they're particularly concerned about Parkinson's disease, as declining motor coordination is a central symptom. So, working with human beings, the researchers pinpointed this nucleus below the thalamus as the region that communicates with that system to stop the body doing something. So it helps humans avoid surprises and react to dangerous and unforeseen circumstances, right? When we're in the process of walking along, we need to stop suddenly, maybe. Or when we're reaching for something and we see we're going to knock something over, we stop. This is what we're talking about. Now, this is a few little cells that are in that brainstem right below the thalamus. They call it the basal ganglia, which is the point at which the information from the brain goes into the spinal cord. Now, from a mechanical materialist point of view, this nerve signal has to work through the whole system to the muscles. From a field point of view, maybe not so much. So what we need to understand is, do we have a field of consciousness, or do we have an electrochemical system, or is there a blend here? What I'm learning more and more, and what more of these studies are demonstrating, is there is no way that a signal is going to be generated at a certain part of the brain in order to stop an action that is already underway in time to stop, say, knocking over a glass. So what we need to understand here is that this marvelous piece of research is saying this is the part of the brain that receives and transmits a signal that is already existent throughout the whole body. So the brain needs to be understood as a receiver-transmitter. But this one continues to say the ingenious techniques that they used was using folks who have Parkinson's disease. They tracked their changes in their motor control activity and then monitored their brain motor control responses using a different kind of thing besides the EEG, but very similar. It's called a transcranial magnetic stimulation. Okay, so instead of electrical, the electric signals, which the EEG, electroencephalogram, picks up, they're looking at magnetic fields. And so they say Parkinson's disease patients are treated regularly with deep brain stimulation, but the addition of transcranial magnetic stimulation allowed the researchers to confirm this definitive role of this part of the brain. Deep brain stimulation, they say, is the only method to causally and systematically influence the activity of the deeply embedded brain nuclei, like the ones in the subthalamus. So we're very excited that there is clear evidence of what part of the brain is associated with motor control. And I'm very excited because it helps me understand and helps all of us understand this receiver-transmitter role of the brain in the field of consciousness that we are. All right, well, it's coming to the end of our time together. That's it for today's show. The next time we get together, we'll look at more of the research that is being done in an attempt to understand what consciousness is, what it really does, and how we can experience life differently when we use it fully. Yes, we are out of time for today, but remember, you can continue the exploration on our website, www.noeticmoments.org, where there's always a list of the shows, the past shows, with the titles and other resources that we refer to on the show, and where you can send me your comments and questions, which I'll do my best to get answered the next time we're on the air. For now, thanks for joining me here on Noetic Moments at KXCR Community Radio, 90.7 FM in Florence, Oregon. And have a wonderful week.
You've been listening to Dr. Ruth Miller's Noetic Moments. This program is produced in the studios of KXCR Community Radio in beautiful Florence, Oregon, supported by you, our listeners. Our theme music is Tumbling Planets, composed and performed by Jeff Lovejoy. To hear this program again or learn more about Noetic Sciences, search our website, www.noeticmoments.org.